Welcome to Convert to Radians, a Pemberton pre-calculus podcast. Episode 5, Review, Part 1. To convert from degrees to radians, you take your angle and you multiply by pi divided by 180. 135 times pi over 180 reduces to 3/4 pi. 240 degrees multiplied by pi over 180 is 4 pi over 3. These are now in radians. To convert from radians to degrees, pi represents 180 degrees. Replace the pi with 180 and perform the calculation. 3 pi over 2 is 270 degrees. 5 pi over 6 radians, replacing the pi with 180, is 150 degrees after performing the calculation. To calculate arc length, which is S, is represented by taking the radius times the angle in radians. For this example, we have a radius of 4 inches, an angle of 90 degrees. Notice the angle is not in radians. We must convert this to radians to do this problem. The arc length is the radius times the angle. The radius is 4 inches. The angle is 90 degrees. Convert it to radians by multiplying by pi over 180 and performing the calculation. We get 6.28 inches. Do not forget units. Area of a sector also must have the angle in radians. The area of a sector is 1/2 times radius squared times the angle in radians. If I give you a radius of 10 centimeters and an angle of pi over 4 radians, we substitute 10 for the radius. We substitute pi over 4 for the angle. Notice it is already in radians, so it does not need modification. And now we perform the calculation. 1/2 times 10 squared times pi over 4. We get 39.27 centimeters squared because we are talking about area. And area has square units, centimeters squared. To convert from decimal degrees to degrees, minutes, and seconds, 12 will represent the number of degrees. The 0.413 converted into minutes by multiplying it by 60 will produce 24.78. The 24 is the whole number of minutes. The 0.78 we need to convert into seconds by multiplying the 0.78 times 60 again to give us 46.8 seconds. Thus our answer is 12 degrees, 24 minutes, 46.8 seconds. To convert from degrees, minutes, and seconds to decimal degrees, 34 degrees. Then we're going to add on that there are 15 minutes in 1 degree, which is 15 out of 60. And then 30 seconds divided by 3,600 because there are 60 seconds in a minute times 60 minutes in a degree for a total of 3,600 seconds in a minute in a degree. And by adding these three together, we get 34.258 decimal degrees. In order to find the value of any of the 6 trig functions, you need to be familiar with the 30-60-90 triangle, the 45-45-90 triangle, where sine and cosine are positive and negative in the various quadrants, and the values at the 90-degree mark, 0, 90, 180, 270, and 360 degrees for both cosine and sine. With these values, we can calculate the 6 trig functions. To calculate the trig functions for 30 degrees, the sine of 30 degrees is the opposite side divided by the hypotenuse. From our 30, 60, 90 triangle, the opposite side is 1/2. The hypotenuse is 1, giving us 1/2. Cosine of 30 degrees is the adjacent side divided by the hypotenuse. The adjacent side to the 30-degree angle is square root of 3 over 2. The hypotenuse is 1, giving us square root of 3 over 2. Tangent is sine divided by cosine. By taking 1/2 divided by square root of 3 over 2, we take the reciprocal of the denominator, simplify, canceling a 2 on top and bottom, giving us 1 square root of 3 over 3, giving us 1 over square root of 3. We must rationalize the denominator. So multiply top and bottom by square root of 3 over 3, and that gives us that the tangent of 30 degrees is square root of 3 over 3. The other three trig functions are just the reciprocals of sine, cosine, and tangent. Cosecant is the reciprocal of sine. Reciprocal of sine is 2 over 1, which is 2. Secant 30 degrees is the reciprocal of cosine. The reciprocal of cosine of 30 is 2 over square root of 3. Rationalize, and we get 2 square root of 3 over 3. The cotangent of 30 degrees is the reciprocal of tangent. The reciprocal of tangent 30 is 3 over square root of 3. Again, rationalize. You'll get 3 square root of 3 on top, 3 on the bottom. And then notice the 3's cancel, leaving just square root of 3. For 3 pi over 2, the sine of 3 pi over 2, which is 270 degrees, if we look at our chart here, at 270, sine takes on a value of -1. So the cosine of 3 pi over 2 is -1. The cosine of 3 pi over 2, which is cosine of 270, at 270 degrees, cosine is 0. And so our answer is 0. With these two, we can calculate all of the others. Tangent at 270 degrees is sine divided by cosine. Sine is -1, cosine is 0, division by 0 is undefined. Cosecant, which is the reciprocal of sine, is 1 over sine of 270. So it's 1 divided by sine of 270, which was -1. 1 divided -1 is -1. The secant of 3 pi over 2 is the reciprocal of cosine. 1 over cosine 270 is 1 over 0. Division by 0 is undefined. And cotangent of 3 pi over 2, which is cosine of 270 divided by sine of 270. Cosine of 270 is 0. Sine of 270 is -1. 0 divided by -1 is 0. For 225 degrees, the sine of 225 has a reference angle of 45 degrees. 225 degrees is here in the third quadrant. We are 45 degrees away from the x-axis. So all of our calculations will involve taking the trig function of 45 degrees. Since we're in the third quadrant, both sine and cosine are negative in the third quadrant. So the sine of 225 is equivalent to negative sine of 45 degrees, which the sine of 45 degrees from our 45, 45, 90 triangle is square root of 2 over 2. So the sine of 225 is negative square root of 2 over 2. The cosine of 225, in the third quadrant, cosine is negative, and the cosine of 45 degrees is also square root of 2 over 2. And so the cosine of 225 is negative square root of 2 over 2. Tangent is sine divided by cosine. If we take the answer for sine divided by the answer for cosine, we will get 1, positive 1. The other three trig functions are the reciprocals of these. If I take the reciprocal of sine, I get -2 over square root of 2, and then rationalize by multiplying top and bottom by square root of 2. I get 2 square root of 2 over 2. And you'll notice the 2's cancel, leaving just negative square root of 2. Secant, same answer because it uses the same exact value, negative square root of 2 over 2. And cotangent, which is 1 over tangent, the reciprocal of tangent, since tangent 225 was 1, 1 divided by 1 is 1. In order to calculate exact values that are outside the 0 to 360 range, we must convert our angle to a number somewhere between 0 and 360, and then turn it into a reference angle. So negative 405 degrees, if I add 360 to it, lands at negative 45 degrees. And if I add another 360 to it, I land at 315 degrees. This angle is between 0 and 360. So the sine of negative 405 degrees is the same as sine of 315. As a reference angle, 315 degrees is here in the fourth quadrant. It is 45 degrees away from the x-axis. And sine in the fourth quadrant is negative. So the sine of 315 degrees is the same thing as negative sine 45 degrees. Negative sine 45, according to our 45, 45, 90 triangle, is negative square root of 2 over 2. For cosine of negative 480 degrees, we need to convert the negative 480 degree angle to a number between 0 and 360. So we add 360, we get negative 120. We add another 360, now we're in between 0 and 360 at 240 degrees. So the cosine of negative 480 degrees is the same as cosine of 240 degrees. 240 degrees as a reference angle is 60 degrees here in the third quadrant. And since cosine is negative in the third quadrant, cosine of 240 is the same thing as negative cosine of 60 degrees. According to our 30, 60, 90 triangle, the cosine of 60 degrees is 1/2, and therefore we get negative 1/2. The sine of 600 degrees, if we subtract 360 now to get it down to a number between 0 and 360, I get 240. The sine of 240, again, has a reference angle of 60 degrees. And sine in the third quadrant is negative. So sine of 240 is negative sine of 60 degrees. Sine of 60 degrees is square root of 3 over 2. And thus, negative square root of 3 over 2. The cosine of 5 pi, every 2 pi it repeats, so we need to subtract 2 pi. I get 3 pi. Subtract another 2 pi, I get pi, which is 180 degrees. If you want to think in degrees, you could also convert this to 900 degrees. Take away 360 will give you 540 degrees. 540 degrees minus 360 degrees makes 180 degrees. Cosine of 180, according to our basic points, is negative 1. And sine of negative 3 pi over 2. Negative 3 pi over 2, if you convert it into degrees, I add 2 pi to this. I get pi over 2, which is 90 degrees. This is negative 270. If you wanted to put it in degrees, add 360 to negative 270, you get 90 degrees. The sine of 90 degrees is 1. You have been watching Convert to Radians, a Pemberton Pre-Calculus podcast. This ends Review Part 1, continued in Review Part 2.